as the software solutions architect, kind of my role is one where I'm interacting with kind of among our sales team and our clients and our internal engineering team, as well as the existing clients that we have. So a lot of conversations of hearing what challenges people have in terms of the experiences they want to create, the different use cases they have across a number of different disciplines and fields. So it's really exciting to just to see the variety of different types of things that can be done with this technology. My background is one of computer, kind of a combination of computer science and art. And when I was looking at different areas that combine those interests, when I found the virtual reality systems, and particularly the CAVE, I mean, almost over 22 years ago, it was really exciting to the first time we would step in and see this virtual world just all around me, as we then network these together around the world. So I joined Mechdyne full-time in 2007, but then I've been working here going back to 2001. So the different hardware technology has changed a lot, but it's amazing to see just how much more accessible and how powerful the tools are to now create the experiences that can be done in these systems. As I described, the system that we're going to be putting together there for UBCO, this is a big display. We've got 40 LCD panels. And an interesting aspect of this is that the way these panels are set up, they can support both immersive VR with stereo and full interactivity, as well as a classroom presentation use case with 2D input. So that really broadens the usefulness of this system and being able to support a number of different use cases. So the 2D use case, it can essentially be treated as a large screen for presentation. It's like a really big desktop. We've got software installed to help manage that big of a desktop. So in terms of tiling different displays or tiling different content, whether it's videos or other applications, and then it can also be switched to use for a full 3D mode. So in the 3D mode, you've got a fully immersive 180-degree wraparound visual experience that completely fills your field of view. For the 2D side, we have a solution called Meeting Canvas. So this is a kind of a collaboration software designed to manage a very large desktop space. So we put this in place at a number of different places. You can bring your own devices. So you can, for example, with your phone, you can, if there's a picture or something on your phone that you want to discuss with the group, you can easily just flick and send content from your own devices to the display. Makes it really, really powerful as a meeting space, and can also be used for particularly for VTC meetings and having groups come together. And another part of that is a very high performance remote desktop solution that we have. So that's going to make it very easy to, without having to follow cables around, but just to directly connect over the wireless and send a high performance remote display of your own devices into the system for doing remote desktop presentation. And then I'm going to be talking about the 3D aspect using particularly the Unity game engine to easily create visual interactive experiences on the system. With any big display like this, the important thing is being able to use it. So what we don't want to have is a system that's turned off. There's no return on investment for a system that's powered off. We want systems that are so heavily used that students and faculty and staff, everybody has to compete for time on the system. So at the large display and big real estate, the important thing is just being able to invite people to come in and to have the tools and capabilities to really create whatever anyone can imagine, and to put that on the system, create the experience for the users that come in. So we look at what is VR. So I mean, it's been around for a long time. Now there's different, more accessible hardware that can bring you consumer level headset displays. And Garth put up the displays of several of the different types of systems that they've visited. But in virtual reality, the key is the screen is your world. It suspends your disbelief as you're looking in the virtual environment. You've got a high quality of display fidelity, high level of interaction, so you're very, very engaged with what you see and what you hear, what you do. So it creates a very rich sensory experience for anyone in an environment. And it's amazing to, I'll talk to one of the examples for one of the sites that how quickly, once you go into the system, any of the, you really feel physically transported into the virtual environment. So currently there's, I mean, the technology has been around for over 20 years. Displays have changed, the computers have changed. Instead of no longer having the big high-end workstations, supercomputers, now you've got smaller, either the clusters of commodity PCs or really big, powerful workstation PCs that we assembled, like the one that will be driving the system here. The applications can be very specialized. But particularly within the industry, there's a big focus on getting return on investment. So big systems, they're complex, but there's very exciting stuff that's being done around them. Head-mounted displays have been around for a while, and now we've got higher resolution that's available. So they're lower cost. You can run them from your desktop. Single and multi-user, they make it easier to experiment with VR and 3D interaction. But wearing something on your head can be tiring. It can be short use. Also issues with comfort, and now also with hygiene, being able to share headsets. You're also cut off. If the user's wearing a headset, you're cut off from collaboration, gesturing, taking notes. It's generally not a direct collaborative experience with the other people directly there in the room. So large-scale displays can be scaled to customize for multiple users, and that's a key thing as we've talked with our clients. One of the biggest things that drives large display systems is the ability for face-to-face interactions among groups of people to actually talk face-to-face as they're looking and sharing in the experience of what's being presented on the screen. So motion tracking is a key part. There was a question on that with what motion tracking brings in. So you've got tracking a head point as the user moves around. So then anywhere that you move through the space, your position is tracked. You can control navigation and interaction to directly interact fully three-dimensionally with the scene around you. Be integrated into the HMDs and the display system. This makes it easy to dive into really complex data. Very natural navigation. You can point and move to just navigate through something. Picking up and moving something is also very intuitive. So it compounds the kind of the benefits of the large display, 3D interaction, and tracking system to give an engaging visual and interactive experience. Why do all this? It can be doing stuff in VR can be safer than the physical environment. It can be used for things like simulation and mission planning, interacting with hazardous materials or hazardous environments, things that could be impossible to explore by other means, so things that have a very large cosmological scale, a very tiny nanoscale. The sense of teleimmersion with having collaboration of multiple people, bringing in design review. We've had manufacturing clients that have identified manufacturing defects that they visually caught by the quality of the visual display, and they were able to catch that during the design stage before anything moved from manufacturing, and that saved them several tens, hundreds of thousands of dollars. It's also great for marketing. For non-experts, being able to sell products or research and just communicate and tell stories. And also, it's just the pure enjoyment and being able to use these for art and emerging media. Being able to have students come in and create content is just exciting. It's always great when we look at the output that students have done in student competitions at their universities. It's great to see the creativity and the engagement that goes into what they make. And some of the challenges that come up in using these displays is that the hardware can be complex. There may not be off-the-shelf options to easily support the configuration of displays. Development can be hard, and users may not know how to get started. Well, about 10 years ago, we were in the process of creating a kind of an interactive platform for systems that we were delivering to our clients. And so one of the examples of this was this virtual shopper for a client that was coming in and doing a virtual shopping of their products. And we had to do a lot of model loading. We added physics. There was customizable scripting. And as we went through all this, we realized it was a lot of work for us to create and manage all of this software capability ourselves. So we said we need to use off-the-shelf game engines that have all of these capabilities already. We can bring in models very easily. We get higher quality colors, rendering, all the hierarchy and metadata information comes in. Get higher quality photorealism, ray tracing, and more importantly, get the ability to have really dynamic characters and behaviors. And so we turned our attention to using the game engines, which made it easy for us to bring data into the system, into the game engine. We still had to do some development, but the programming resources was very different for using a game engine versus low-level C and C++ development that used to be done years ago. And so Get Real 3D is what's going to be delivered on this system, but it's really just something that we made that let us leverage what was already available with Unity to create and author content. And so that meant we could really create anything that we wanted using the game engine and the tools that it has. We could develop simulations, the physics are already there, kinematics, the VR tracking and controller use, we were able to bring that in. And so it reduced all the complexity of putting a complex interactive experience on a cluster of PCs and to manage the synchronization. We chose Unity because it was a really powerful engine, had a great engine for doing real-time rendering, get high quality lighting and materials, dynamic terrain, physics and kinematics, audio. There's a visual editor which makes it really accessible to create and control the experiences. And now that can be done without writing any code. There can be effectively drag and drop of components into a scene to set up the behaviors. There's also a very large user base, so that makes it easy to bring in external assets. So there's an asset store where you can just go out and, including free assets, just download different components and different features, whether it's models or script behaviors, to import those into the scene. And that's really powerful because that means even though looking to create experiences on a large VR display system, we're able to leverage this entire community that is out there that has just a tremendous wealth of other content available to use. So the editor, you can easily do things like create 2D interfaces, bring in models, and so I'm going to walk through some of the different things that we and our clients have also put together. So, for example, here's a view of a manufacturing robot running within the editor. So it's a really visual, direct interaction environment. And then when it runs on the system, this was just a simple two-wall staging system. All the animations, everything else, all stay in sync among all the displays. For architecture, there's a bunch of workflows, and actually now there's some different tools that automate the workflow of getting data from Revit, Navisworks, and Rhino directly into Unity. This was a case we were doing an evaluation on an apartment building. So there's the model on the left, and then on the right is the user actually experiencing it in the cave. As we were walking through, we were checking the bulkheads and clearance through some of the entrances. This was another system that had a reconfigurable walls that actually open and close. So being able to do that, let them kind of change based on which space they were evaluating for their design reviews. They would change the display configuration, whether it was more of a wide open space or something that was tighter. Seeing everything at a one-to-one scale allowed them to do the walkthroughs and just visually catch where they needed to make adjustments. This was another system, the UIC Cave 2. This was a 36-node system. This was the cave at Iowa State University. So they did a project where they were showing off to potential football recruits what it might look like as they walk out on the football field. And so using the game engine, they actually had the stands the crowd in the stands were animated. The football players that came out on the field moved through formation. So all of this kind of dynamic behavior that they were to implement with the game engine made it just a more seamless experience of actually having, not just looking at a model, but really engaging with a dynamic virtual world around them. Another university did a firefighting simulation where the gaming program students actually worked with firefighters locally in their community, and they created this simulation where overhead rafters were on fire, and so using a mock-up of a hose, they had to aim at the correct direction and pressure to extinguish the fire before the rafters would actually fall. So the engine provided the burning and all the internal simulations to create the behavior of the building burning. We did a cruise ship event a few years ago where they had the model of the ship, and they wanted to do a big unveiling of this vessel, but I guess about 3 weeks before their opening, the CEO said, well, I don't want to just look at the model. I want to actually, when I'm up on the roof or on the rooftop garden, I want the plants to have the leaves blowing in the wind. He wanted to have the sounds of the band playing. So we came in, and using Unity, we were able to do both of those. So the plants would blow, the band would play. There were actually people that were walking around on the pool deck. So instead of just walking through a CAD model, we were actually walking through a populated, busy ship with people walking around the pool. You go into the restaurant bar. There's a bartender serving people drinks. So all this kind of just created a more dynamic environment. They also wanted to do things with a dynamic configuration, where the lower left there was an artwork down in an interior part of the ship, and so using the game engine, we were able to set up a user interface to just quickly cycle through different iterations of that artwork, so that they could look at and compare what they wanted to look at. And the sense of presence can be so strong. So the CEO he did the first walkthrough of the demo. Of course, he'd been running in this system for the entire week, so he had the speed turned up really fast on the navigation. So we're up on the outside of the ship, and then he quickly zoomed down into the interior, and everybody that was visiting who hadn't been here screamed and ducked as they flew into the ship. So he let someone else drive the rest of the day. But I thought it was a great example that for everybody that was there, as it looked like the bulkheads were flying right into their foreheads, that just seeing everybody that was standing here just all duck in unison, I thought was a good indicator of just how strong that sense of presence in the environment is when someone's experiencing something in these. We've also done a multi-user system. So if we consider multiple caves kind of connected together, we can use the game engine to leverage multiplayer capabilities. So you could actually go into a collaborative experience going through a training scenario. We've used oil and gas is really big on safety. So being able to use the engine to create simulations that let them explore and train on hazardous situations without any exposure is really important. So we did. There was a project where we were creating a training scenario for a gas plant leak. So there's a liquid leak in the oil plant, and the visuals were really what the subject did in the environment was not as important. What was important is that this training was actually about their audio communication. So they had a microphone, and they were talking with it's like a desk operator, and so they had to radio back in the correct sequence with the correct acknowledgments of what they observed through the environment. And so being able to do that virtually meant we could change the environment and just kind of script the sequence of events as they go through learning the right things to say and respond. Another use case we had was a safety inspection for scaffolding, where users would have to actually scan with their head to look at certain things of the scaffolding to verify whether it was correct or not. So the things, for example, in the upper right, they'd have to check to make sure that there was a wood block under the base of the scaffolding. Or in the lower right, they'd have to verify that the ladder is properly attached to the scaffolding. All of this was based on being able to train their eyes and to move their head in the correct direction as they looked at the display. So they'd actually look up and down, because these all mimic the behaviors that they would need to do on a real site. We also created a fired heater shutdown. So the important thing when doing a shutdown for a heater is that if the right sequence isn't followed, then it can actually cause a flashback, and that burn is really dangerous and can kill people. So using the scripting the behavior lets them actually go through and dynamically create the sequence of going through that shutdown. One of the exciting things with this was that we actually had some additional monitoring in place to monitor the heart rate and see how they responded once they were given the commands. Also been doing experimental projects with using the game engine. So whereas we used to have to use customized software, now just using the game engine, we can connect these up with robotic simulations, other components that will actually do additional monitoring. So with the motion tracking, we can track where the user is, where the virtual robot is, and this was a case we're actually studying they're studying the proximity between the participant and the virtual robot to try to get an assessment of, is there a level that they start to feel uncomfortable. We've also been doing a project looking at a construction site drone safety. So as an aerial drone approaches subjects standing in the environment where we have a force plate on the floor, so we're tracking where they, as they move, we can actually measure and feed that into the environment to measure their loss of balance. We also measure their heart rate, and this lets us collect the data and determine does the drone fly too close. So the game engines are being used a lot for creating content for design decisions in manufacturing. Bringing the content in lets them see the environment, experience kind of the visual placement of stuff. And the large display makes it easy to have multiple people all in there for cross-functional collaboration. And this lets the interaction among the team really flow. And that ultimately leads to improved workflow as they can actually assess the ergonomics in factories, plants, and work cells. And so with the hybrid environment, you're going to be able to actually drive all of these at the same time. So doing 2D interaction, for example, on one side and having 3D on the other, there's just a blended capability of what can be done. And so really the invitation is just to consider data-rich storytelling. What are the stories that you have to tell and want to present, whether it's educational concepts that have complex 3D structures, digital heritage, training and simulation, arts and communication. As you just look at all of the different things insights, whether it's experimental research, design reviews, different collaborations. Using these big displays and the engine and tools that are available just give you more ways to engage, visualize, and interact with the content. So it's exciting, and there's really just no limit to what you can do. So that's kind of a quick overview of a lot of the different types of works that we've done. So I've opened up for any questions. Thank you.
Thank you very much, Chris. We do have a couple questions here. The first one is, with the use of Unity, do you think that non-technical people can also participate in the development or maintenance?
Absolutely, and that was our primary reason for where we've had the turn off the sharing. Our engagement with Unity has actually been primarily centered around exactly that fact. The development in Unity can be used either with JavaScript or C#, but there are visual tools to create the interaction without doing really any code. And so that's been, we think, one of the biggest benefits of it is just the accessibility of Unity's development just makes it broadly applicable across a bunch of disciplines.
And how does Mechdyne facilitate the collaborations between the technical team and the client's subject matter experts? Can you share some best practices?
It's really just having those conversations. Getting everyone involved openly in communication. One of the common things that we've run into just from a business standpoint, if there's one group, for example, driving, or I guess the purchasers of the system, but then ultimately what we always strive to do is make sure that we're talking to everybody that would be involved in running a system. That means who are going to be the people that have to turn it on and off, and making sure that a client has resources to do that. Who are the professors that actually want to drive content on the systems? Which content do they want to drive? Can they? We often work during our process to get demo content, so that when we're, for example, when we're creating a system for a client, that we can unveil it and make it possible really to hit the ground running with content that's relevant directly from you. So we always seek to get sample data from the professors or from the students, so that it's really just making that communication open, and talking to get the data and just experiment with it, visually explore what can be done. One of the nice things with Unity is because it can be so quick to develop and show something. We try to really just push on the iteration, just trying something, experimenting with short, small steps, just to constantly get something out there and get feedback.
And I think at the moment, that's all the questions we have. If anyone has another question, oh, one has just come in. How do you deal with visualizations of abstract 3D dimensional data in a rotating space? It is a challenge in one of our projects right now to make something like this.
So if it can depend on what type of data. I mean, if it's point clouds, there are ways. I mean, points can be splatted at a certain size, or if you're creating ISO surfaces. I mean, we'll utilize, for example, ParaView as an open source tool. We'll use that a lot for if there's actual data viz that has to happen, and then we can bring the visualization output into Unity. I guess I'd have to. I want to know more about. If you can tell me more about what that format, what the data actually is, because that may lead into how you would actually visualize it.